thank you so much again for attending the session today. And I'll just start very quickly, jump into this thing by way of introduction. I was for about 28 years a professor of structural engineering at University of Arizona, and then I left at the end of 2010 and started this company QuakeWrap, which is our 32nd year. And along the way, I also became a licensed contractor. So some of these projects that you see, we have done design build, just so that you get an idea of how it works. The good news for you folks is that I have absolutely no equations or conclusions even in this presentation, but it is full of solutions that we have developed, and hopefully you can see how you can implement these in some of your projects. Also, a couple of housekeeping notes. I will be sending you a copy of these slides, so you don't need to copy them or anything. You'll get a PDF version of these. We have a YouTube channel that has over 250 videos. And then there are some of the specs and details of some of these products are available on our website. You can download those as well. So I'm not sure really how much you have background in the FRP products. So I'll start out by giving you a very brief introduction to FRP, with the old system, which we call the wet layup. And then the bulk of the presentation is on these new products that we have developed. So the whole thing really got started back in the early 80s when I was in the beginning of my academic career. We were trying to come up with a way to solve corrosion problem, which was, in the structures because of corrosion of rebars. And, I jokingly say I had a full head of hair there and I was a lot better looking, came up with this idea back in 87 that why don't we use non-metallic materials like carbon or glass fabric as reinforcement. The problem was that in those days, carbon was really expensive because it was being used primarily by the military. But luckily, about that time in 1989, there was the end of the Cold War, and the military's interest in these carbon products went down, so the cost went down. Also, about the same time, there was, if you call this 1989 Loma Prieta earthquake, where in that Nimitz freeway, the columns of the bridge collapsed because they didn't have enough ties, lateral ties around the columns. So we took this idea, which by then we had been playing with in our lab for a couple of years. This was an opportunity. I've said, why don't we take this carbon fabric and wrap it around the columns and make it earthquake resistant? So the namesake of our company, QuakeWrap, comes from this one particular application. But of course, over the years, we have made a lot of other changes and improvements in this. So what FRP, or fiber reinforced polymer, if you look at the name, it comes from a polymer that I'm showing here in red. This polymer could be either epoxy or vinyl ester resin, and that is being reinforced with these fibers that I show in black dots. The fibers could be glass, carbon, Kevlar, and so on. The function of the matrix or the polymer is twofold. It protects the fibers from abrasion and damage like that, and it also distributes the load uniformly among the fibers. And one major difference between FRP products and other engineering materials is that these products are anisotropic, meaning that if you have a plate of the FRP, it doesn't necessarily give you the same strength in X and Y directions like a steel plate would. The strength of these comes from the amount and orientation of the fibers, which are the main load-carrying element. But as you'll see, this is actually a feature that can be very beneficial in many of our designs. So this original system, which is now 40 years old since we introduced this is called the wet layup system. And it consists of rolls of fabric that, the white one that you see on the right is glass, the black one on the left is carbon, and then different epoxies that we mix the fabric or saturate the fabric with and apply it. So this video shows you a very basic way of how this would work. Here we have a series of bricks that are not joined together in any way, and we are trying to make a quick beam out of it. So this one epoxy that is like a toothpaste consistency, we call it the tack coat. You put that on the back of the bricks, and to kind of smooth out any sharp edges and so on. Then we take this fabric, this other epoxy, which is a consistency of like honey, and we roll that into the fabric to saturate the fabric. Then we pick up the fabric, put it on the back of the beam, and with a gloved hand, you get rid of any of the air bubbles, make it stick well. This takes maybe about half an hour, 40 minutes to make this beam. You let it sit in ambient temperature. The next day, you see when you put the fabric in tension, you have created a beam that can take a lot of load of these 4 guys. And not only that, that same next day, you can drive a truck over this, and you need to notice that when it fails, the failure is in the compression of the brick rather than the fabric. So this is kind of like the very basic idea of the system. By the way, just a reminder again that, as you see, like on the top of this slide, there is a link to the video, and when you get the slide deck, you can watch those videos. So in a very simple case, by the way, ACI Committee 440 has design guidelines that you can follow. They have examples that you can follow, and it shows you how to strengthen a structural member with externally bonded FRP. But just to give you a simple case of it, let's say if you have a slab or a wall that has number 7 rebar in it. Every number 7, as you know, can take a force of 36 kip. Now, imagine that we are going to use a carbon fabric that has all of the fibers, in this case, in the direction of the arrow, nothing in the other direction. But if you made a coupon of this fabric and tested it in tension, as you see here, every 1 inch of this fabric gives you a tension force of 6,000 pounds at breaking. So if you put a 6-inch wide strip of this fabric, gives you 6 times 6 or 36 kip. And that is the same force as that number 7. So you can say that 1 layer of this fabric equivalent to having number 7 rebar at 6-inch on center. And of course, you can see that with this one, you don't add any weight or thickness to the structure, and it is much easier to install compared to doweling rebar in a concrete slab or wall. So that's kind of like the general idea. Now, the advantages of FRP: they have high tensile strength, they are very lightweight, they don't corrode and virtually last forever, and they're easy to install, as you saw. Now, one of the ways to consider this is that, when you take a new, brand new steel column or girder, and before you put it in service, you paint it. Why do we paint that? Because the function of the paint is to keep oxygen and moisture away from that steel and prevent its corrosion. Think of this FRP, even if you don't want to give it any strength or any credit for all of its strength, think of it like a layer of paint that is about 0.1 inch or 0.05 inch thick, that is never going to crack and peel off. So I'll repeat this in many of my applications. You'll see we talk about creating an impervious shell around your structure to keep it from corrosion or stopping the ongoing corrosion. And one other point to note here is that, I know our environmentalist friends complain about these milk cartons and plastics that we throw in the landfills and they never decompose. Well, I hate to tell you, but these FRP products that we're talking about are even much more longer lasting than your milk carton, because the resin matrix is a lot stronger, and the fact that they have these fibers in them, it prevents them from cracking and breaking down easily. But hopefully we can all agree that if there's one application when you don't want your material to decompose and break down easily, is when we are fixing these old infrastructure. So these composite materials really are ideal for these repairs. As I mentioned, ACI Committee 440 has this document with including a lot of design examples at the end of it. I won't go really through the details of these. I wanted you to get the overall idea, but this is available. AASHTO has a similar document for design of highway bridges and so on. Other countries also have their own codes. So just before we get into the the bulk of this presentation, I want to tell you a little bit about our own company's organization. We are kind of really unique in that we come up with a lot of ideas. We have over 20 patented systems, do our own engineering design. We have our own manufacturing facility. A lot of the stuff that you see I'm showing you, we manufacture them ourselves. And then we have our own in-house research and development lab that we do testing, as well as work with other government agencies. And then we have a construction team that install these in the field. So it is all, like come up with the idea, do the engineering, build it, test it, install it in the field, and then, improve on it. And this design build model so far has worked really well for us. Our products have been installed in 28 countries. We have done over 1,000 projects in the last 32 years since we've been in business. Having said that, I want to emphasize that we team up with a lot of engineers like yourselves, as you may be the engineer of record on a project, and we can give you our portion of the design to include on your design package. And the same with other contractors as a GC or subcontractor relationship. So we welcome really the opportunity to collaborate with you. Now, let me just start with give you a few examples of that wet layup, what I call the old version in my thing. I refer to that as the DOS version or the landline version of it. And the next things that I'll show you later are the iPhone version or the Windows version, which are more exciting. So this was a bridge in Lordsburg, New Mexico, about 20 years ago in New Mexico. There were two 9-span bridges. The one that you see is the westbound bridge that they finished first and put all of the traffic east and west going over this one. During the construction of the eastbound bridge, one day the inspector tells the contractor, it looks like you're not putting enough steel in the deck. He says, no, this is exactly how we finished the westbound. Well, long story short, they realized that he had left half of the steel out of the deck of this brand new bridge that they had just completed a couple of months earlier. So I remember, standing under that bridge at like around the midspan, and when these trucks were going over it, all these cracks would open up widely and fluttering. But instead of tearing this brand new bridge down, just like you saw with those brick beams, we put these strips of carbon fabric under all of the 9 spans. And now 20 years later, whether you drive on the east or westbound, you cannot tell the difference between these bridges, and it's been doing great. Another application is, this was in downtown Phoenix a few years ago that we teamed up with WSP engineers. Here, they were widening a section of this I-10, which is about 70 years old. They were adding a couple of lanes on both sides of the I-10. And as you notice, there is this Arizona canal that goes under the I-10. So there was a pair of box culverts under this section. The box culverts were corroded, and they were wondering, should they repair these 70-year-old box culverts, or should they replace them with brand new ones before they widen the road? Well, we ended up repairing it for them. So here is the cross section of the box culverts. They're 14 feet wide and 5 feet tall. They did have a 6 by 6 inch fillet at the ends, but the WSP engineers, they said, they would like it to be enlarged to 12 by 12. So you see here in the lower left, we are doweling the rebars in the corners, and then we put a slanted formwork at 45 degrees, and through that white and red is the grout port. We injected the grout, and on the lower right you see the finished enlargement of the fillet. This part of the job actually took a lot more time to make enlarge these fillets compared to the actual strengthening of it. So the strengthening of it consisted of putting these 2 feet wide bands that were roughly 14 feet long, putting them along this span. The length of these culverts, by the way, was about 385 feet or so. We also made sure that the edges of the 2 feet wide fabrics overlapped by 1 inch or so. Not that we needed all of that for strength, but we wanted to create a completely impervious and that moisture barrier sealing for this culvert. So the sealing of it now is completely covered, and then it was as you see on the right side, and then painted it. Now, cost-wise, the WSP's estimate of the replacement cost for this culverts was $25 million. And of course, you can imagine how much traffic closure in the middle of downtown Phoenix this would have cost. We repaired both of these for only 5% of the replacement cost, with only 1.3 million over 2.5 months, and with zero disruption of traffic. The guys that you see on the left actually are crew doing the installation. The traffic is moving over their head. So for quality control, there are different ways that you can assure that. One is you can record lot numbers of the fabrics and epoxies and where they go. Then ACI also has some standard tests, like an adhesion test. Basically, you take these pucks that are 2 inch in diameter, you glue them to the surface of the concrete or the FRP, and then core around it, and with a device you pull on it to see at what load it breaks. And they say 200 psi is the minimum acceptable value. In many jobs, we get 700-800 psi, as you see on the dial here. Then another way is for strength of the fabric itself. You can saturate the fabric, put it between layers of glass panels and let it cure on the job site. Then later on, you send these like 12-inch by 12-inch panels. You can send it to a laboratory, and they cut them into 1-inch wide strips and do a tension test and report on that strength to you. But another thing is companies like ourselves, and there are a few others that have that. We are ICC or IAPMO certified. And so our products always get an annual check for quality assurance, and that's one more layer of assurance for you. So you saw some of these applications, for that one, wet layup. We can do it, on these culverts, bridges, also, in mines, we repair pipelines and liquid storage tanks and so on by wrapping the fabric around it. The one advantage of this fabric, the old system, is that it conforms easily to the shape of whatever you're putting it on. So when you have an AASHTO girder with this kind of profile, these fabrics make the repair easily achievable. We usually on these jobs, we repair a couple of the lanes one night and then move the traffic over to the next lanes, and the next line finish the project. Now, this is, a 21-year-old job that we were doing with the old system in Indiana for Indiana DOT, and I wanted to point something out to you that how our new system is going to be so much better than this. So in this case, where the column of this bridge was corroded, the solution requires that you clean the rusting. You have to patch that deformed concrete, make it smooth, because you cannot apply the fabric to a rough surface. You can put it on a smooth surface only. So you patch that, then you have to wait for the patching material to dry. And then, as you see in the other photos, we wrap the fabric around the column, and that's how it has been done for decades now. But now we want to get into our this is our Windows or iPhone version of the products, and we start out with the first product, which is called PileMedic, for repair of corroded piles, or even if you have missing piles. And again, I want you to pay attention that if you have, for example, a missing pile, you can see that there's nothing you can do with that fabric, which is so flexible. So in our manufacturing facility, we take that like a roll of fabric, let's say that is 4 feet wide, and we apply heat and resin and pressure to that fabric. And from that flexible fabric, we make a laminate that you see in the center section. These laminates are about 0.04 or 0.03 inch in thickness, but they're very strong and they have fibers in the X and Y direction. We ship them to a job site, as you see on the left. A roll of the laminates is 4 feet wide by roughly, 300-400 feet long. You can, we can cut it and give it to you in shorter lengths if you need. Then we also have ways to, if you're repairing a pile, as you see, and it doesn't go all the way to the mud line, we have a way of sealing the bottom of this so your grout that you put in there doesn't fall through. So let me, the middle one, it shows you also the spacers that we make. These spacers are, we make them in 1, 2, 3, 4 inch, and they are put around the pile and they create the annular space that will get filled with grout. So let me show you what, like on this recent job, actually from a couple of weeks ago in British Columbia, let's see how this system is installed. So the first thing is you put several of those spacers through a zip tie and put them around the pile, as you see. If you have any reinforcing elements at this stage, you can put those. Now here we are putting these carbon strips. Sometimes you can put, FRP rebars. And then you cut the length that you need from that fabric. Our typical detail is to go 2 complete tears and 8 inches. So you cut that length and you apply epoxy on the second half of that cut length, and then you wrap that around your column, wrap it around it like twice, and create a shell, like you see. You hold this shell together with, some ratchet strap or these zip ties while the epoxy is curing. You can seal the bottom of it, and then in this case, we are filling the annular space with an epoxy grout. But you could, in some jobs, you can do, cementitious grout and have a GFRP rebar in there. There are various ways of filling that annular space. And so here is the finished, like a 4-foot tall repair, or if you have a taller repair, you would do multiples of these 4-foot repairs and go all the way to the top. This is an application, the final day that the military was approving our product. So you see here, we have an 8-foot jacket, and with that pump at the bottom through that grout port, they are pumping the grout to come up and fill the annular space. And you also see the bottom seal at the bottom of it to keep the grout from coming out. This is one of our very first use of PileMedic. So you see this job in Florida. We didn't have all the bells and whistles and the spacers there, but you see the contractor can cut the laminate from the roll. This epoxy that we provide cures underwater, so you do not need any cofferdams on any of our projects. And here it was a shallow water, so they walk in there, wrap the laminate around the column or pile and hold it together with these ratchet straps, and then fill the annular space with grout. And here is the finished project. This system has been tested extensively by a lot of, like Texas DOT has done a study of $500,000 at University of Houston to do this for axial load of H piles that are corroded. Caltrans did a study about concrete piles that get damaged in a bridge and quickly repaired with this system. See how quickly you can put them back in service after an earthquake. Nebraska Department of Roads has done a study of this for timber piles, but the largest study was done over 3 years, a multi-million-dollar study by the Army Corps of Engineers for concrete and timber piles. And as a result, we are the only product that is approved for the military's use, and we sell these regularly to the military. And of course, we've done some other tests with electrical utility companies like Tucson Electric Power for strengthening of utility poles. So, on a typical repair of, let's say, submerged pile, as you know, you may need to add longitudinal bars, and then you have to put ties around these bars to hold them together. So typically, you make a rebar cage topside on the deck, and then you have to handle these 3-dimensional heavy rebar cages underwater. This becomes really cumbersome to handle for the divers, it may require a couple of divers or maybe even a crane to lift this up and put it in place. But in our case, we make it a lot simpler because, as shown here, if you put those spacers and then put the rebar, snap vertical rebars one by one in place, we don't need any ties. When you wrap our jacket, this jacket, if you go 2 times like we typically require, the jacket itself is equivalent to a number 4 steel tie at 2.8 inches along the height of the column, and it is far more than what normally you would require. So this PileMedic eliminates the need for reinforcement ties, which is really saves a lot of not only materials, but a lot of time and makes the job go a lot easier. And then also, again, realize that when we do these repairs, you have a completely seamless jacket, so the entire height of the column will be encapsulated in this shell, and you would choke off the corrosion process because you stop the inflow of oxygen and moisture. This was a project, unique thing that we did about 10 years ago in Australia. The piles on this bridge, they were suffering from alkali silica reaction. If you know, this ASR is something that some people refer to it as a cancer of the concrete and causes expansion of the concrete. So prior to us doing the repair, they had used 2 different systems, but each of those, after 2-3 years, the jackets would bust because they couldn't resist the expansion force of those columns. So here, we are repairing this. You see on the upper right corner, the contractor has cut the laminate and puts the epoxy on it, and then down on the lower left, they pass it down to the diver, and he starts wrapping it around the pile. The fact that you see this diver is working in a cage is nothing structural. This river is infested with crocodiles, and so that was just for safety to protect the diver from crocs. But on the next slide, you see there were 4 piers on this bridge. Each of them had 10 piles, so we did a total of 40 piles in here, and this was done, as I said, about 10 years ago. We have published a couple of papers on this project in ACI and another one in the International Bridge Conference, and those are all available from our website if you like. Here was a project, 500 timber piles for Purdue Agriculture in Chesapeake, Virginia, a few years ago, 10 years or so ago. And as you see, when you have these hourglass shaped or missing portions of the pile, we can put the rebars and the rebar bridges across that, and then with the jacket we create a shell, and basically we build a new reinforced concrete shell around that older pile. We've been repairing over 300 of these in the last few years with the Canadian rails in these remote systems, and they like that because it doesn't take a lot of heavy equipment. So of course, if it snows like it did here, you have to protect the epoxy from freezing, so they provided some heat in there. But in this case, how we are repairing these, we don't use any spacers, and we wrap the laminate directly onto the timber, very tightly around the timber pile. The non-uniformity of the surface of the timber does create a little bit of an annular space. And then as you see on the far right, we mix a low viscosity resin and pour it in that annular space. That resin, by gravity, fills all of the voids and cracks in the pile, and you end up with a very strong pile with hardly any enlargement of the size of the pile. A question often asked is, what do you do with these cross members? You can remove the bolt if you'd like, put a wooden peg in there. Then once you wrap the jacket and fill the annular space, you can pull that wooden peg out, and if you like, connect your bracing member through the same old bolt. And on the right side, again, I'm showing that how when you have tight spaces, these laminates are very thin, and you can easily wrap them or get them in there between braces if needed. Now, in repairing concrete or timber piles, you have a good bond between the newly cast concrete and the host pile. But if you have a steel pile to repair, you don't have a very good bond between that old steel. So one possible way, of course, like you do in bridges, is you can weld shear tabs. But a lot of these jobs that we work on, they don't allow hot works or any welding. So we have developed a new solution. It's called shear wrap. These are 280-degree, like half circle steel loops that we design for each project. And then they are put around the pile and tightened to a specific torque. So let's say here, if we have, we may require 3 or 4 of these above the damaged area and 3 or 4 of them below it underwater that you can't see now. And then, of course, once you put the rebar and put the, PileMedic jacket around it and grout it, you won't see these shear wraps, but they are inside of that grouted portion doing their work. And the way they work, let me show you here. So let's say, this is a shear wrap and it has these wings also for added bearing capacity. But if you have a damaged portion of your pile, you will tell you how many of these you need above and below that. And then when you put the jacket and fill it with grout, now as the load comes down here, you notice that when it gets to that shear wrap, it bypasses the damaged steel, goes through that ring of concrete, and then down below, it goes back into the good portion of the steel pile. So with this system, we create a continuous load path without any welding. And these are some real applications of it. You see in the middle that this fellow is installing it with a torque wrench, and the wings that I was talking about, you can see. In some of these jobs, if required, this was a project in Mexico we were doing, you can anchor the longitudinal bars to the underside of the pile cap if you're trying to develop a moment connection. So we can do that as well. And there is a version of this that we call shear clamp for H piles, and you put those individually around the flanges of the pile and torque it, and each of them is good for a certain capacity. And here is just like one of these jobs that, we did this a year ago in Seattle. And just a couple of things to keep in mind. FRP products, cannot withstand the heat of welding. So you cannot weld to them, you'll damage them. So, and it is a lot better if you can make a continuous tube rather than fighting with those, anchor plates and gusset plates. So in this project, for example, as you see on the left, we had these braces. We cut the bracing elements, and on the center, you see that the jacket has been built and going all the way to the top. And what you don't see under the jacket are these, shear wraps have been installed, which you don't see. But then once the jacket is installed and it is grouted, on the outside, we designed some new, brackets that are bolted to a specific torque again. And that way now we install new bracing members. And so you have a whole, new structure independent of the previous bracing system. Of course, in these places where you don't have any braces, it's easy. You just go all the way to the top. And these are the grout ports that you may use multiples of these to fill the annular space with grout. And this just shows how, we designed those brackets. You don't need to worry about that now. But, one other thing to point out here, this was a project we done some 9-10 years ago for the Nigerian Petroleum Corporation, repairing these concrete piles. And to remind you that if you have a concrete pile, you don't need to worry about load transfer. There's good load transfer between the old new concrete and the new concrete. And I also like to joke that this is, we are the only ones I know who took $1 million from Nigerians, for this project. But all right, now I want to get to a different type of products that is made with a sandwich construction. And we can use this in repair of culverts as well as seawalls and a lot of other things that you'll see. So if in, these carbon fibers, they're really good in tension. And if that's what you need, you can use a couple of layers of them and they're pretty, they're pretty strong. So let's say I have a job, and in the middle, I have showed these two green layers, two of them stuck together. Let's say that represents 2 layers of carbon fabric. And for the sake of argument, let's say each layer of carbon fabric installed is, let's say, $30 a square foot. So in the middle, I have a $60 a square foot solution. Now, this is really good for tension, but if the job requires some rigidity of the solution, then one option, of course, would be to add a lot of layers of carbon on top of each other, but that becomes really expensive. So what we do is we separate those 2 carbon layers by putting a core material in between. And you see that if you put that, enlarge it by double the size, you get 7 times the rigidity. Or if you put a little bit thicker core in there and make it 4 times the thickness, you get 37 times the rigidity. So you really get a lot of money for your investment. So here, price-wise, for example, if the middle one was $60 for that 2-layer system, when we go to the one to the right of it, it may be $70, and then to the end it might be $80, but you've got a lot more stiffness out of it. There are different core materials that we can use. One of them I'm showing here is a 3-dimensional fabric. These are 2 layers of fabric that are stitched together with very fine glass fibers, and you saturate the 2 layers together. But during the curing process, if you let the 2 layers sit on a table, for example, through a wicking action, resin is sucked through the bottom, and the top layer kind of rises and cures at a distance away from the bottom layer. So you end up with, as I show here, with 2 solid plates with a series of webs separating them. So we have a very rigid, lightweight structure. That's one of the products that can be used as that core material. Now, one application of this is what we call StifPipe, is for making pipes. And let me just go to cases, and on the cases, I'll show you how we will do this. So let's say this was a job in Australia, and we were repairing an 80-foot long culvert. So we start by this mandrel, which it has telescopic arms. We can pull it to any location, dimension that we want. And then we put a sheet on the outside of the mandrel and wrap the layers of glass and carbon and that core material, whatever we want, around that mandrel, and let it cure overnight in the shop in ambient temperature. The next day, we collapse the mandrel and we have a finished piece of pipe. We pull it out and repeat this process. So this job, that the culvert was 80 feet long. We made 4 pieces of culverts or StifPipe, 20-foot long each. And then on the job site, here's the culvert. They bring this to the job site. We push them, slip line the culvert with these pieces of StifPipe. The ends of these 20-foot sections, because this was a big enough pipe for man entry, they would go in there and put a layer of glass fabric over a 4-foot wide band over the ends of these, so we make it continuous. And then the annular space that you see here is grouted. So the thing really is that, like in this case, which was a very remote site, look at this. 2 guys are pushing a 20-foot piece of pipe just by their own hand without any equipment. And that really, like on some of these jobs, this could save a lot of money by not having to take heavy, pushing or jacking equipment to the job site. And we've done a number of these, double cells, single cells, as you see here, up to, the biggest until a few years ago was this 10-foot diameter that we had done in Australia. But another way that this system, StifPipe, can be used is if you have a project where it is difficult to slip line it with a pipe, we can take the materials inside of the pipe or tunnel and line it, and layer by layer apply it the same way as that StifPipe, like build a StifPipe by using your host tunnel or pipe as the mold for our material. And that's what we were doing in this project in downtown Minneapolis, where this tunnel is about 150 feet below grade. So we took the material down a shaft, and then they traveled to this damaged area, which was very severely corroded and weakened. And we built a fully structural liner layer by layer, inside of that pipe. So that's one thing. But the biggest of these, slip lining job was a job we did last year, was finished. This was a world record setting job that we made these 16-foot diameter pipes to line a tunnel that is 17.5 foot in diameter in Detroit. And here is, we also developed a non-destructive testing system to check the pipe segments before they were delivered to the client. But you see how massive these pipes are. It was on the cover of this Composite World magazine because of its unique size. And, if you clip the wings of a Boeing 737, it would fit inside of this pipe with 4 feet of room to spare. So it's really a massive pipe. And the fact that we made it in Michigan, that was another unique feature of our technology. So think of it that if you have a project in Kansas or in Wisconsin or wherever it is, we'll be able to make you a pipe probably nearby. Now, that same sandwich construction that I mentioned, we use it in repair of seawalls or sheet piles, and we call it sheet pile repair or SPiRe. So the way this works is, let's say if you have a corroded seawall, we would make these panels 4 foot wide flat, 4 foot by any length that you want. We could make them angles like the one in the middle also. And this job was a project we were doing about 900 feet of seawall in Chesapeake, Virginia. So the process starts by cutting a hole in, multiple holes in the seawall and putting an all-thread J-bolt hook behind that, so that is secured. Then if we need any additional rebar with that original SPiRe system, we would put them in the annular space between the webs. And then these 4 foot wide panels are brought in front of the wall, and they're connected through those bolts that we had installed. The edge of the panels, they overlap by 4 inches. And in this system, we've already made improvements on this one. But when we were doing it like that, we would put an epoxy over that 4-inch so they would be bonded together, all of these panels. We create an impervious stay-in-place form, basically. And then if needed, we can put some strong backs on the back of them to minimize their deflection during the grouting procedure. Then the annular space is filled with grout. So with this system, we have we don't really rely on the strength of the SPiRe panels, but it's just like a stay-in-place form. And then one advantage of them is that they are so light that the divers can swim with them. So here are 2 divers carrying a 4 foot wide by, roughly 10, 12 feet tall, but just swimming it in place. And this helps a lot when you have these, like under the decks of these piers where you cannot lower a heavy steel plate from the top, for example, with a crane. You cannot reach under the deck, but with this product, you can swim it, and that makes it a lot easier. At the end of the grouting, then these bolts that come out, we can cut the bolts, and we have these caps that goes on top of it, so it's fully encapsulated and it won't corrode anymore. This system, we have used it on many projects in US and even overseas. The biggest job that is right now ongoing is 1.2 kilometer or 3/4 mile of a seawall at the port of Melbourne in Australia, but a bunch of other projects in the US also. The military buys this, and we train them. This was in Port Hueneme. We were training them, and then they buy these panels and take them to remote islands in the Pacific or wherever they have to do the repairs. This was a unique application that the contractor did to repair this breakwater in Florida, in Santa Rosa Yacht Club. And as you see, you have a very severely corroded seawall or breakwater, but the bottom of it is usually in good shape because it doesn't get so much oxygen. So what he did, he sandwiched these panels on both sides with through bolts, and then poured a grout in between. And here's on the right, you see the beautifully finished project. Okay, I want to show you, please, let's watch this video together, because look at how we came up with a solution for this project at the end that has become our best-selling product. So let's watch this together, and then I'll see you on the other side.
This industrial terminal at the port of Galveston, Texas, presented significant challenges. An estimated 50% of the steel reinforcement was lost to corrosion. Repairing the structure by building formwork with heavy timber in such a tight space below the deck proved to be impractical. Such repairs would require placing new reinforcing bars around the structure, building the formwork on site, placing concrete in the annular space, removing and discarding the timber formwork, which would leave the structure exposed to the corrosive environment. That is when QuakeWrap was contacted to provide a cost-effective solution using one of Professor Ehsani's patented systems. Our solution using the SPiRe system consisted of building custom-made FRP shells in our manufacturing facility in Tucson. These shells include a rigid core and layers of glass FRP on the exterior surface. The panels are 3/8 inch thick and weigh 2.2 pounds per square foot. Non-metallic GFRP rebars were inserted in the shells in the field. The lightweight shells are lifted from below and secured with anchor bolts to the host structure. A non-shrink grout was pumped through the grout ports to fill the annular space. Once the main girders were repaired, the transverse beams were repaired in a similar manner. The completed project is shown here. The use of the SPiRe panels not only saved time and money during the construction, but the impervious panels also act like a thick layer of paint that will protect the host structure from salt spray and corrosion for decades. Based on the success of this project and realizing that GFRP bars had to be added to the shells in the field, we have developed a new product called SPiRe Plus. These panels have all the benefits of the original SPiRe panels, plus they have built-in reinforcing bars in the shape of T-profiles. The panel itself is also grit-coated for improving bonding to concrete and to serve as a reinforcing element. That combination results in the panels being equivalent to number 6 grade 60 reinforcing steel at a spacing of 3.5 inches on center.
So let me show you now some of these applications, how this works. So these are the panels that you see. They come in 3 feet wide by any length that you want, the 12, 18, 20, what have you. And we can make whatever shape we want. We also have like a angle shape that you see here. You can put on the corners of these, so you can make a box shape of any size as well. And let me just take you through a bunch of these. And it's amazing in the last 3 years, 2.5 years that we have introduced it, how many projects we have used this on. So this was a testing of these that we were doing. We are making some beams that are 10 feet long and basically 8-inch wide, which includes 2 of those T-profiles and 4-inch thick. So here is the load deflection. There's no steel in this. The only reinforcement are the panel and the SPiRe Plus panel and the 2 T profiles in there. And based on these tests, we have determined that this is equivalent to number 6 grade 60 rebar at 3.5 inch on center. So like an application, for example, this is a bridge in South Carolina. Now, as you see in the middle on the left, how a lot of these exterior girders of these bridges, they get hit by overhigh trucks, and it's always a pain to try to, you have to close the traffic. It takes a lot of effort to build up that concrete. Instead of that, with this system, you can assemble a formwork offside, adjacent to the bridge, and just one night for over a few hours, pick that up, bolt it to the sides of your girder and pour your grout in it, and that would be pretty much it. And then this would stay in there permanently, protecting the girder from future corrosion. This is a job we just finished a few weeks ago at the port of Long Beach for Carnival Cruise Terminals. Look at these. These are a couple of dolphins that we were repairing, and look at how severely corroded they are. So on the piles, we repaired it with our PileMedic. You see our shear wrap installed here, and that's for the piles. But then the cap portion of it was repaired with that SPiRe Plus. So here is the finished project, on that site. And again, keep in mind that now with this system, we have fully encapsulated this structure in a thick layer of FRP, like a thick layer of paint that is never going to come off, and it would prevent it from, corrosion and for decades. This was a timber wall that we repaired, timber seawall in New York. And in this case, the contractor showed that he could drive these 3-foot wide panels with a vibrating hammer, push them into the silty soil. And then we have a special all-thread anchor that you connected to the deteriorated timber. On the tail of this lag bolt, these are like 12-inch long lag bolts, but on their tail they have a threaded piece that we can thread an extension all thread, and then that extension comes out of the panels, and we secure it through that extension. And then at the end you can of course trim the top, and you can see they have grouted the space. It is nicely done. This was a project in Western Florida. We did a couple of these pump stations for them, and they're severely corroded. Now, in some cases, if both sides of these structures are accessible, we can sandwich them between the layers. Or on the right side, you see in pictures where you have access only from one face, then we put the panel on the outside face of it. This building, is a coastal resort in North Carolina where the pre-stressed concrete, the cables in this pre-stressed concrete decking of the floor was corroded. And you know how tough it would be to repair or splice a pre-stressing cable. So instead of that, we mounted these panels from underneath the slab, bolted them to the underside of the slab. And you see if there's any pipes passing through, you can cut through the SPiRe Plus and let it pass through there. Then the contractor chose to drill a hole from the floor above and pump the grout from above. And on the far right, you see this, nicely finished slab, very smooth surface. What you see now is again like a 0.2-inch thick layer of that FRP from SPiRe Plus that is going to protect the structure from corrosion. These are our, we make these grout ports is a part of our system for PileMedic that it can screw in from just the outside of the jacket, or for SPiRe Plus, we have a different version of it that can be bolted to the side of the SPiRe Plus, and then those quick release cam locks, they can connect for pumping of the grout. And this other application was a bridge in North Dakota that the pier walls were damaged by abrasion. And, the contractor put these 3-foot by 9-foot tall panels, put them all the way around both of these pier walls, creating a tiny annular space. And then we fixed with the grout, filled that with grout. And even though this was the first time that the contractor was working with these, he managed to finish, both of these in 3 days. And the last thing I have here is an application we are doing in Florida for rising sea levels. So in this case, you can put these panels, attach them to the edge of an existing seawall, or if you're repairing a seawall, you can extend them taller than what normally the height of the seawall would be. And then on the other side of it, you put a panel in front of it and bolt them together and fill it with grout. So, here you see kind of a rendering of what it would look like. And on the land side, you can add walkways, planters, or benches to make it, more attractive, and we're doing a couple of jobs like that in Florida. So we are, that original SPiRe Plus, we are right now in the middle of testing a new version of it, which is thinner when you don't need all of that strength. This is only about 0.9 inch or 23 millimeter thick, and we are, as we speak, we poured the specimen concrete on it 2 days ago. So we'll be testing these in the coming weeks and introducing this in a few months to the market. This would be really almost like a substitute for your plywood sheets. When you have, instead of using a plywood to form anything and remove it, you could use these and leave them in place, and it gives you a lot of strength as well. So if you are interested, I have a monthly podcast for infrastructure repair. You can scan this if you'd like, or when you get the slide deck, you can join us on those. In that site, you will also see we have about 25, 26 former episodes that you can watch. And with that, we have come to the end of it. This is the slide that you can scan. If you scan this, it would take you to a site where you put in your name, and it would be you would receive your one PDH certificate by email. So I think I managed to go quickly through these, but we are under the time at least. So I'll be happy to answer any questions that if you have.
I think there's a question in the chat.
Yes, let me look at that. The chat. For a new structure in a highly corrosive area, would you recommend an FRP pile? Has there been any testing on that? Yes, although we do not make these, I know there is a company that makes basically tubes out of FRP that you could use it as a shell. I suppose you could use that as your casing and then build, fill it inside with reinforced concrete, so it can be done. We don't make that product, but yes, that is an option. And it would be a good solution, really, if you have a corrosive environment. I mean, we have been using steel for decades, and we know what happens to it. So it's about time that, we start looking at some other materials.
I have a question.
Sure.
Is there any deterioration due to UV light exposure for these products?
Oh, yes. Oh, I'm glad you mentioned that. Very good point. Our system, which by the way is, I'm holding it so you can see what it feels like, the flexibility of it. This is that PileMedic laminate. This is the only jacket system that is available on the market with a built-in gel coat on the outside of it. So with this product, you're just like any sailboat and motorboat that you see. It has that gel coat, and it has a very long service life. With the SPiRe Plus product, the standard one does not come with a gel coat, but we can do that as an option. We can put a gel coat on it before you apply this. But with this, I really felt like we don't need it for all cases, because what happens when you have UV, it starts to give a little bit of deterioration and discoloration on the outside of it that is exposed to the sun. But this one, for example, it is 0.2 inch thick, this plate. And first of all of your T profiles, which are the reinforcing elements, they are all embedded in concrete. They never see any sunlight, so no worries about that. And even if you have a little bit of a flaky or damage on the skin of this, the whole thing is 0.2 inch thick. So if you can afford to lose a little bit of it without really losing much strength. But if somebody doesn't like the appearance of it to be, discoloration and so on, we could optionally add a gel coat on this. Yeah, that's a good point. I'm glad you asked that.
And one more question.
Sure.
I noticed you're wrapping deteriorated concrete elements that have rebar that is already corroding, so it's expanding. What do you have to do anything to that rebar before you cover it?
No. So let me, now that we're on this, I can show you. So really, like this is actually a mock-up of our pile repair system. So when you put these rebars that we put, by the way, the rebars, they get snapped into the spacers, very nicely, so we know where they go. So when we make this these rebars, we design them based on what percentage of corrosion, you have lost your rebar due to corrosion. So then, the new addition to the concrete would take a lot of the load, and the old corroding rebar really will not be able to corrode like before, because it is now doesn't have access to oxygen or moisture. With the system, when it is fully encapsulated, you really bring the corrosion rate to a halt, and it is much better to address it this way than put, for example, these kind of cathodic protection systems. They work well, but the problem is that people retire or records get lost, and then people forget about replacing the anode when it is consumed, and at that time then you have an accelerated, much faster corrosion. So with this system, really, once you repair it, you can forget about it, for the life of the structure.
So I think we bumped up on time. I want to say really appreciate it.
Thank you so much. Me too. I really appreciate it. And again, feel free if you have any questions in mind, just email us. We would, it won't cost you anything. We would quickly look at an alternative, and we can give you an estimated repair cost, including installation. So you can have that, just for your records as comparison with the other method that you're considering.
All right. Well, thank you, Dr. Mo.
Thank you so much.